Too many. I'm going to run this every hour. 15, and we're going to say where the number of results is greater than 400, because that's what we said we're going to alert on, or 4,000, right? 4,000.
So is that where you said there would be an issue if you clicked real time, you would really need to beef up your...
Yeah, I could set this alert as a real-time window, like for 4-hour window, and it would count. So every time an event comes in, it creates, in essence, a new block that has to track for 4 hours. Every time an event comes in, it creates a new session that it has to monitor for the time frame you set. And so this will get swapped into disk because you know you have enough RAM for this. And it will just destroy your performance. Especially if you did something stupid like a 4-hour window. But people do stuff like that, you know? I mean, if you did a 10-second window, that wouldn't be so bad, right? Depending on how many events you have in 10 seconds. It wouldn't be that bad. So I'm going to list it in the triggered alerts as a low priority. I'm going to send an email to myself. I'm going to tell it, that's fine, it's going to give the name of the search. I'm going to have it send to me a CSV with the results. I'm also going to have it send all of these events in line. And I'm going to have it run a script to raise an alert to the knock, you know, raise up alarm.sh, right? And it tells you it has to be located here on the search head that you're running, right? And we do this. We have stuff that raises alarms. We say if the traffic, if your answer to seize ratio drops below whatever, raise an alarm that there's a problem.
So is that a script? Is that a script you have?
I just made that one up, but my script's called send21c by OVO.
Whatever you would do to send
You have to create that piece, right? You have to create that glue, because you have a proprietary interface for raising an alarm and clearing an alarm in your knock. And we can do both with the scripts. And we're going to trigger the alarm once. Just once, not for each result, right? Because otherwise we get 4,000 alarms, which that.
But if you're continually getting that, then every hour you get another.
That's right, and you can throttle it here. You can say, once you get one of these, don't send another one for 60 minutes. You know, so we've got this event where we've got too much traffic, getting too much errors, and our server can't keep up with it. I will only see one of these every 60 minutes. No matter how many times I run this and see that the problem still exists, it'll track the alarm history and say, the last one was here, I'm within this window, don't do it again. And then I save it. And it's live. It's now doing this. It's that easy. And now if I go over here, I can go to, where is the alarms? Activity jobs alarms. That should be here. Triggered alerts. Since I told it to do this every 4 hours and the 15 minutes, eventually we'll come back here. But I don't see any alarms now. But I will. This will start alarming I told it to run every hour. So we'll start seeing those alarms come up. And you can actually use the Splunk, native Splunk, as your alerting system. Right? Let's say you're starting your own company and you have your SLAs that you're trying to make sure you're doing this or that, and you promise people whatever. But you don't have, you know, a national data center with all these engineers looking at the screens like the AT&T guy showed. You're just you, right? You need to get an email when something's wrong. But you also need an alert history where you can, once you clear it, you can see and you can tell it to keep the alert around for a certain amount of time and expire the alert. All the normal stuff you can do with your alerting system, you know, whether it's SEV1 or TTI-FAM or I don't know what all you guys use. But you don't have to use that. You can use it just here. This can be sort of your one-stop place for all of that stuff. Your single pane of glass for monitoring your system, for dashboarding, for alerting, for notification. All of that stuff can happen just with your standard Splunk install. Typically, in my experience, people don't. They have their own alerting system, and this feeds into that. But it's very easy to do. You just have to build that one piece of glue. the script that you call that sends the alarm. And there are a couple of examples. And Splunk actually has an app called SNMP Trap. So if you already have something that's generating these traps, you can actually point this to, you can start up a Splunk instance running this app, a forwarder, and you can send the traps over there, and Splunk will reformat those traps in a good, nice, solid, clean text, and with the proper fields, based on the trap syntax. And you have your trap data here, and then you can look at that. You can have, instead of going to your NOC to look at all of their alarms, you can actually look at them here and do other stuff. Because Splunk has a bunch of business logic that you can do that probably these trapping systems can't do. So you could actually send the raw traps here and then reprocess them and send them out as traps again with that script. Okay, so this is showing a chaining of commands. It's just like the shell. If you guys are used to the Unix shell, you pipe commands together. So, for example, a very common command is eval, which creates a new field. So Splunk, if you're going to do Splunk, the one thing you have to come into it with is if you're going to be any kind of an administrator or power user, is you're going to have to know regex, Perl compatible regular expressions. You're going to have to know that or learn it. It's not that hard. I didn't take a class. I just started Splunk and I learned it. I knew a little bit from Perl scripting, but you got to get really good at it, and you'll continuously need to get better and better and better at it, because that's what it uses to pull out the fields. So you can set it up where the fields automatically extract, and they're baked in at the index time, where they come out only at search time. Or you can ignore that completely and not do a data model and just do your own on the fly, and that's what this is doing here. You see it says rex. Rex is where you say, take a field that currently exists and apply this regex pattern to it to create more fields. And so in this one's saying, take the raw field, which is underscore raw is the raw event, and generate a field called table, which starts with either from or an into. So this is looking at SQL commands that have been run. This is SQL log, and it's saying what tables are being modified, right? And so this is real log data that if you guys are using MySQL, it's generating these logs. This is an example of how quickly you can say, well, tell me who's doing what in the tables, and let's see. Oh, it's generating an average transaction speed into it and out of a table, right? So it's performing statistical analysis right out of your raw data. Now, what's interesting is if you go back here to events, I click on the events tab, it's going to show me the constituent events that made up the results of that search. Oh, it didn't show me because I'm in smart mode. So there's smart mode, fast mode, and verbose mode. Fast mode does not carry any context along with you. As soon as it's like automatic garbage collection. As soon as you don't need it anymore, it throws it away. Smart mode says, well, he's been using this field, so I'll carry that field along with me. Even though now that I'm done with it, I don't need it. He might like to see what it was when it was calculating it. And then verbose mode says, anything that ever happens, carry all of that along with me. So if you go and you say, I want to back up from a visualization to a statistic or to an event, and you don't see any events, it's because you told it to go more quickly and not carry those with you as soon as it was done, throw them away. And so I can see here, by clicking on the Events tab, here are all of my constituent events, and I can see that there's an insert into sessions, right? These are the raw logs. There they are. And I've been able to take 100,000 events that are in here, and in just about 2-3 seconds, give me my average database response time across all of my transactions. And I can do whatever I like with this. I can generate a dashboard. I can generate an alert. I can drill down and say, well, wait a minute, customers is doing something weird. Let me see what's going on there. And if I click on customers, then it's going to go up here and it's going to say, it's going to tack onto it, pipe search table equals customers. So it took the search that generated the results, and when I clicked on it, it said, oh, here's what I need to tack onto that search to eliminate everything else except for what he clicked on, and then it puts that in as another search. And then I can go back in here, and it gave me the search, and I can save that search and do something else.
How do we see the schema that's
Okay, so
underlying?
the schema came with it. Splunk understands a bunch of the major data types, but if, for example, in telecom, or you got your own proprietary data, you're going to have to build either a field extraction or a data model, which is two different ways of doing the same thing. One's like a command line way, and one's more of a GUI way of doing it. But you're going to have your data subject matter expert who knows how the data is partitioned. Somebody has to apply some level of schema. Now, if you just know that there's an IP address in there and you're guessing and you're going to call that source and you're just playing around with the data and you're going to say, well, I think that's this and I think that's this, you can do that on the command line with that rex command, right? And actually there's a field tool. So you can click into the field tool and say, Splunk, you tell me what you think fields are based on the pattern, because every event has what's called, what Splunk calls a punctuation. And that's where Splunk starts with its understanding of what fields might be. And in this data, see the punctuation, it says it looks like this. It basically eliminates all the characters except punctuation and creates a string. And it says if the data is of a similar type, it will have a similar punctuation structure. And you can actually count. Like when I first go into a data set and I don't know anything about it,
So what is that saying, for example, punctuation? What is that?
if you look at your data here, the punct says, I see a bracket, followed by normal characters, followed by a slash, followed by another slash, followed by an underscore, so it takes
Okay.
all of the characters out except the punctuation, and it creates a string called that.
It looks like it's always the same format.
Well, in this case, what you see here is you have 3 different punctuations, right? And so these are definitely going to be 3 different kinds of logs. And so if you don't know anything about your data, you just sucked it in, one of the first things I like to do is go into the data and do stats count by punct. And just take a look. You know, what do I have? What are the outliers? It's like somebody says, I need this data because I need you to tell me this, right? Because it's really important and it's in the logs. And you say, where is it in the logs? I don't know, but here, it's in there, right? And so you put it in here and you say, okay, well, let me sort by count, right? Let's assume if this is important, there are a whole bunch of them, if it's in here. And I'm going to just click on this. I'm going to say, well, what are these? Show me these events, right? What events match? And then you say, oh, well, I can see these are where we're selecting from products. Oh, these are product ID searches. This is probably what he's looking for. Who's buying this? Who's doing that? I went right from not knowing anything about my data to being able to sort of home in on a particular look and feel kind of the data. And now I would be able to say, okay, the punctuation might vary a little bit, but I know that my thing is going to have from products where product ID, and I can just search for that in case the punctuation is a little different, and then I'll know I've got all my data. But to hone in on what's important, not knowing anything about the data, that's usually where I start. If I go in to help customers and they don't really know what's going on or what their data is or how to use it, they don't have their expert that's already done the data models, we're going to have to build some data models. Well, you're going to have to know something. This is a good way to start discovering it. Somebody's going to have to watch me on time. So I'm getting a bunch of questions. So when my time's up, you let me know. I got a bunch more questions
You got
here.
2 minutes.
2 minutes. Well, okay.
Mark out.
You started out with mapping the log files, right? So
Right.
Somewhere down the line it came into, I see, the MySQL.
Right, because it has different log. So your sandbox generates, I believe, fake SQL logs, fake web logs. I think it has some weather data, some FAA flight data. These are all fake
Right. So
data
you're
streams
really
going in.
we are trapping the web in this particular case, the web traffic and putting it into Splunk,
Right.
rather than we directly hitting the execution or the data layer itself of MySQL.
Right, these are, yeah, we're not querying MySQL. It's leaving vestiges
Okay,
somewhere
it's
that we're
back-
forwarding on,
okay.
right? So this is all after the fact.
Got it.
But you can tell Splunk to timestamp something when it sees it, which I think is stupid, but a huge number of people do it. I don't get it. But what you need to do is tell Splunk, in this source type, so you have it, every log that you ingest, you have to tell it where the file is, and you can assign one or more source types. And you say, for this source type, you can find the timestamp here, and it looks like this. And when you ingest it, use that as the timestamp, not now. Right? And every log has a timestamp and an index time. So you can actually compare those. You can see with Splunk, well, compared to when I saw the log, when was it generated? And you can look for latency in your report. You say, this is not right. There's something wrong here, like after the daylight savings or whatever, something in my data doesn't look right. You can actually compare what you think, what your latency delivery into Splunk is and what it should be and what it actually is by comparing those two times. That's another search you should regularly do in your data to make sure nothing weird is happening. Because if Splunk can't find a timestamp, it'll do one of two things. I'm not sure when it decides to do what. It'll either say, well, I recently found a timestamp, like the log above me has a timestamp that I did find, I'll use that. But if you have too many where it can't find a timestamp, it'll just give up. It'll say, and I don't know the algorithm between those, but it'll say, I'm just going to use now. I can't find a timestamp. I don't know what else to do. I'm going to use now, whatever time now is. So generally, your log shouldn't have index time and time as the same. You've got a time location problem in your settings when you tell Splunk where it is. There was maybe one more question. Is that a sign?
No, white, muck and white.
Okay. So you chain commands in the normal way. And so if Splunk, if you've done a chain that is obviously visualizable, Splunk will automatically create the most natural visualization on it. Here, I have a table which would make one axis and times, which would make another axis. So Splunk will create automatically a basic visualization that matches how many rows you have and the kind of statistical thing you told it to do, whether it's a stats or time chart or whatever. If you do time chart, it's going to create some kind of a time series. If you do stats, it's going to create some kind of a bucket with volumes kind of thing. So that's what it did here. It created this automatically. Now I can take this and I can save this as a dashboard panel, just as is. And it will go out and it will create a dashboard and it'll save it there. And anytime somebody goes to that dashboard, it will run the search and generate this result. And in this case, the search was the last 4 hours. So anytime you go to the dashboard or refresh it, it'll say, for the last 4 hours, show me this. And you can set an auto refresh, or you can put a time ticker on the dashboard so the people that go in there can change the time. You can create a form where, like, they would say, well, the guy might only like to see one table. So you can have him input the table name and then run the search. All of that is doable as well. And it's very, very, very easy. If you just go to YouTube and look at the tutorials, if you say, I'd like to build a dashboard, a form that does this, lets me search this, there's one out there. You just watch a tutorial, it's very straightforward. It's very GUI. It used to not be, but as a Splunk 6, they have multiple ways of doing it, and they've simplified everything. It's really, really easy to use. And I think I'm pretty much out of time. We already talked about alerts.
Could you say something quickly about the patterns?
Sure.
So how does that work? What does it do?
Oh, you're talking about the tab that says patterns?
Yeah.
I haven't had any reason to use that, so I'm not sure that's new in the last release. So that's just outside of my time and scope and need. So I'm not sure about that.
What, could you talk about the use cases? You don't SNMP, you don't the web traffic, right?
Right.
What are the use cases that you have dealt with?
Okay, so Splunk has 4 basic use cases. I don't think I'll be able to remember them all. One is compliance, whether it's SLA or government regulations or whatever. I have to prove that I'm doing what I'm supposed to be doing. All right, it's really good at that. Splunk only sells, besides license, they only sell 3 products. One of them is a PCI compliance app. It is excellent. It is excellent. If you don't have any PCI solution and you're out of your waivers and grandfathering and you have to get a PCI solution in place, it's expensive. I think it's like 10 grand. But for a company, that's not that much. You can buy this app, have the professional services come in and tune it for your application, and you can be done in like a couple of days. It's really slick. Another one is SEIM for security, right? You want to make sure that when people are trying to break into your stuff, that you have a record of it, that you notice it, that you alert an action on it. That's another app they sell. They sell an app called Enterprise Security, something like that. And it's amazing. Again, before Splunk wrote an app, they won a security award, just with their vanilla product with no app. And since they've written that app, they win every year. They're the best security appliance on the market. They win awards everywhere. It is unbelievably excellent. And this is just one thing they do. They didn't start out trying to do that. They just decided, we're so good at this anyway, we're going to write an app and sell it and win all these awards. And it is excellent. But that's the kind of thing where you have to put it in and let it screen for a week or two to figure out what's normal, and you have to say, no, that's normal and that's normal, but it's really good. So that's another one. Then you have your business intelligence, right? I'd like to figure out what's going on and make a decision to change how I'm doing what I'm doing because it's going to save me money or make me more money. That's another use case. There's also like subpoena compliance, if you're going to be a nice guy. And some places you have to help the government when they say, like in our case, we have an address space, an IP address space, and the government will come to us and say, we know this bad guy just did a drug deal or robbed a bank or whatever, and we saw him post, I just robbed a bank, and here's his IP address, and it's a T-Mobile IP address because he's on his phone. I need you to tell me who this guy is. I need you to take that IP address, map it to a user, go into your database, tell me his phone number, tell me who he is and how I can reach this guy. None of which you can tell just based on your Twitter feed necessarily. But we can find that out. If we have a way to get into our logs and do the queries that we need. And I built a subpoena compliance form for my guys, and they used to respond, and they'd say we can do it in less than a week, and now they can respond in like 2 minutes. When the government calls them in, our subpoena compliance has all of these newspaper and awards about all these drug busts and stuff they did, right? And I can say, I did that, I helped them do that, right? So I think we pretty much comply with anything that comes to us, even if it's not a subpoena. If we have a good relationship with the police and they say, it's an emergency, we need this right now, we will get a subpoena, our guys can do it now. Before they'd say, well, you might as well get the subpoena, just take us that long anyway to get the data for you. But now we can do that.
So, Greg, have you talked about Tableau?
I have not talked about Tableau.
Okay.
So one of the weaknesses, we should have done that?
Yeah, no, I was thinking this. I think there are people who are going to be using Tableau, so let them come to you.
Okay.
Later in the session. I
Okay.
think there's going to be more.
Hey, it's your show.
No, I think Slide 4 is next. So
All right.
You're going to be around, right? So,
Yeah. Oh, yeah. I'm staying the rest of the day. I'm
Asking
really
more
getting
questions
something out
about
of it.
There you go, Greg.